So as I was telling you just now, the difference between transverse and longitudinal waves, if they ask you to distinguish between them, distinguish between transverse and longitudinal, what you can do is you can just state the two definitions. Alright, so transverse waves are waves where the direction of oscillation of particles is perpendicular to the direction of travel. Longitudinal waves are waves where the direction of oscillation of particles is in the same direction as the direction of wave travel. But there are other differences as well, so let's look at some of the differences. Now, so if you want to see the movement, you can actually imagine you're using a slinky spring. If you move up and down, then the wave will travel along this way, right? So that means the wave travels this way, the particles oscillate. So that's transverse. If you take the slinky spring and you give it a push, then the wave will travel this way. So the particles oscillate parallel to the wave travel, okay? Now, what are the differences? Now, this part polarization has been actually removed from your syllabus, but it's good to know a little bit because sometimes they will ask a little bit outside the syllabus. So what is polarization? Basically, polarization means making the waves oscillate only in one direction, or selecting only one direction of oscillation. For example, if I take a slinky spring, I can always oscillate up and down, right? But I also can oscillate sideways. Agree? So as I oscillate sideways, the wave will still travel front, but it's still oscillating sideways with still 90 degrees, right? So all these are called transverse waves. But you can oscillate up and down or sideways or diagonal, right? All these are transverse waves as it travel. But if you only select one direction, then it is called polarized. Okay, for example, if I make a vertical slit, okay, a cardboard, and then I put a vertical slit in my cardboard, so only the one traveling vertically will pass through. The one moving side to side cannot pass through, right? So then when it comes out, it will be only up and down. For example, initially I use my hand, sometimes I move up and down, sometimes I move left and right, so I keep on generating weird waves. But if I use a slit here, then only the one moving up and down will pass through. So that's called polarized wave. Whereas longitudinal, you can't, because longitudinal, the moment you put in, let's say, a slit here, okay, I say, oh, I only want to select one direction. How? Because your wave just travel front and back only, so every direction means just pass through or not. So therefore, longitudinal waves cannot be polarized. That's it. Okay. Another difference is transverse waves may not require medium to travel. Example, these electromagnetic waves. Now, electromagnetic waves do not need any medium. Okay, that's why the light from the sun can travel through space, which is supposed to be vacuum, and still reach us. But all longitudinal waves require a medium. Example, the two types of longitudinal waves that we talk about are usually seismic waves and sound waves. Both require medium. That's why sound waves are in a vacuum, you don't hear anything. Okay? So many people don't realize that, when you watch like Star Wars or Star Trek, they shoot each other, the spaceship, you hear choo 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 choo. Actually, it's supposed to be a silent movie. Because in space, when they shoot each other, there's no sound. And then when they explode, also no sound. So it's perfectly silent. But it wouldn't be fun anymore, right? But that's why longitudinal waves all require a medium. Okay? Right.